Okay, good afternoon everyone. So for this video, I will discuss lesson 6, the last topics for the AC generators. So here is the outline for this discussion. So first, I will discuss about the power developed in the armature, and one of that is the how to compute the maximum power developed in the armature. Next is about the power losses and efficiency of the alternators. Third is the parallel operation of alternators with given internal and external parameters of the generators. Fourth is about the percent speed regulation of generators. And lastly, the effects of change in excitation and change in the steam supply. Okay, so before that, I would just like to illustrate to you the parts of the AC generator, or what we call the alternators. So the stationary part is what we call the stator. So muna dira ang nakita na tong kaning atong field winding and our permanent magnet, and the rotating part there is our rotor, So the field winding mo ni siya makita sa to ang permanent magnet, while ang armature winding katong makita sa to ang rotor nga part. Okay? No, then kani siya kay naa siya brushes. So kaning black duha ka buok mo ni siya ang mga brushes. Then kaning duha ka rings, these are called the slip rings, and we have this external na circuit na load. Okay, so let's start. So first topic is about the power developed in the armature. So asa gitong armature katong nasa tunga, no, kani this is our armature. So what is the power developed in the armature? So for big alternators, no, sa mga dagko nga mga alternator or AC generators, the resistance in the armature is very small compared to the reactance, and that makes it their resistance negligible, no, tungod kay ang resistance kay gamay na kaayo compared sa reactance, then murarag si resistance kay ma-equate siya sa zero, no, or negligible na siya, no. So without the resistance being considered, then the power delivered is equal to the power developed, no. So na-deliver na power ani niya is just equal to the power developed. So ang mga losses ato kay gineglect. So that is for the case sa mga dagko nga mga alternators. So the power developed or the power delivered is equal to, so this is for the per phase, and this one is for kanang line voltages ang given, no. So sa phase we have 3 times E of P V of P over XP. So unsa ganin E of P, that is the induced EMF per phase, no, kani dere sa circuit, that is the induced EMF per phase, while si VP, that is the terminal voltage per phase, over the, so di ba sa formula nato ani kay impedance ang tani, since our resistance is negligible, no, zero atahang resistance, so mabilin na lang kay ang inductive reactance nato, which is C XP, that is per phase, multiplied by sine alpha, no, or sine phi angle nato. So that angle there is the power angle, and that is the angle between our induced EMF per phase and our terminal voltage per phase. So if line naman ang given, no, if induced EMF line, no, o terminal voltage terminal line voltage ang given, then walaon lang to nato si 3. So let's have an example. So a 60 MVA 69.3 kV three-phase alternator has a synchronous reactance of 15 ohms per phase and negligible resistance. The alternator delivers 48 megawatts to a bus bar at the rated voltage with its field current adjusted for a generated EMF of 46 kilovolts per phase. Determine the armature current. No? So let us recall sa formula na itong gigamit sa previous na itong lesson. We have E of P, or the induced voltage, is equal to the terminal voltage per phase plus the armature current, or the current per phase, multiplied by our impedance. No? So, dari na ito nga formula, makuha ang value sa ito ang current. No? So, before na ito makuha ang atong value sa itong current, we should know unsa ato ang E of P, or induced voltage, or our terminal voltage, and our impedance. So sa itong impedance, dali ra kayo, no, since ang given nato is negligible atong resistance, so R nato is equal to 0. So ZP, di ba? ZP is equal to RP plus J XP na reactance nato. So, since negligible naman si resistance, so 0 na siya, mabili na nato is our reactance, which is already given, no? Synchronous reactance of 15 ohms. So, automatic ZP is equal to J XP, which is 15. So, J 15. So, na natay ZP. So, itong pangitaon na lang is ang value sa itong EP and sa itong VP. So, unsa may pinakaunang sayon nga kwaon, no? So, ang pinakaunang nga sayon is the terminal voltage. So, we are given with 69.3 volts, no? So, if wala gani siya giingon, if it is connected in parallel or in line, no? Na I mean delta or Y na connection siya. We always assume nga naka Y connected ni siya, no? Or naka VL ang ato ang given. So that's why we will convert this into per phase nga voltage. So ang equivalent niya is equal to, i-divide lang natin ni siya og square root of 3. So we have 69.3 kilovolts, no? We divide it by square root of 3 so that we can get the per phase nga voltage niya. So we have VP equal to 40 kilovolts. Then to solve for our induced voltage, no, we are going to use the formula since given man ta og delivered power, no? Nag-deliver man daw siya og 48 megawatts na power. So we will use this given, no? So sa atang na-learn ganihang nga formula, no? We have the delivered power is equal to 3 times EPVP over XP. So, mana siya ato ang gamiton. No? So, we have this one, dayon sine, then sa tong angle. So, since given ito ang power delivered, so that is 48 megawatts. So, mega means times 10 to the power of 6. So, atong equate siya ani. Next, we have 3, dayon EP. So, aha man ni si gikan si 46, no? Given na pod nato ang ato ang EP, no? E of P, or the induced EMF nato. So, given ta og EMF of 46 kilovolts. So, natay 46 times 10 to the power of 3. Then, na-add natay VP, which is 40K over ator X. P na to, or the reactance, which is equal to 15 multiplied by sine angle. No, atong gikuhaan ni is the angle. Diba? Kay sa atong VP, automatic that the angle sa atong VP is 0, but ang angle ani niya sa EP ang nato ang pangitaon, no? Para ma-solve nato ato ang kaning IP or phase current, no? So ang atong unknown dere is the angle, no? After substituting the given ug atong solve nga mga values, so we are going to solve for the angle, no? Saan man ipag-calculate, so i-multiply lang nimo si 48 times 10 to the power 6 by 15, then i-divide din nato siya anin ni 3, dayon ni 46 times 10 to the power of 3 ug ni 40 times 10 to the power of 3. So nanakay value ato. So nanatay sine angle is equal to katong value. Wala mo gud calculate dere. So after that, para makuha nato ang atong angle, ato lang siyang i-inverse sine. No? Inverse sine lang sa to ang nakuha nga answer or value. So makuha na dayon nato ni nga value. So this is the angle na dayon sa ato ang E of P or induced nga voltage. No? So manipulating this formula, kani EP is equal to VP plus IPZP, i-divide nato, una i-transfer si VP sa other side. So may mo siyang negative VP, so manan negative VP. Then divide both equation by ZP. Para mabili na lang sa pika sides equation kay si IP. Then you substitute the values sa imong IP, that is 46 times 10 to the power of 3. Angle niya is 7.49 degrees minus ang VP na to. VP is 40 kilovolts, or that is 40 times 10 to the power of 3 angle 0 divided by our ZP. So natay ZP dere nga J15, no? After that, makuha na din nato ato ang value nga current per phase, which is equal to 547.31 angle negative 43.08 degrees, no? So, or yung magnitude ana is equal to 547 amperes. Okay, by the way ha, basta mo yung kag angle ani niya sa current nato, if ang atong angle is negative, then ang atong power factor is lagging. Naglag na siya. So lahi pud sa power, no? Baliktad ang sa power. Kung sa power, then negative yung mga angle, then leading power factor po na siya. Okay. So next is about the maximum power developed in the armature. So kansa man siya mahimong maximum ang power nga na develop or na deliver. No, the maximum power developed will occur when the power angle is equal to 90 degrees. So remember sa atong formula kaganiha, naman to siya nakabutang nga sine angle, no? So at maximum power, ang ato na angle is equal to 90. So that's why we have sine 90, and sine 90 is equal to 1. That's why in this new nga formula, nawala na to si sine angle dere sa kilid. So the same lang Japon nga 3 per phase na voltage o EMF over XP diyan sa line po na to. The same lang siya. So another example, so an 11 kV 3-phase Y-connected generator has a synchronous impedance of 6 ohms per phase. No, impedance, no, that is Z per phase man daw, so that is ZP. So natay ZP equal to 6 ohms and negligible armature resistance. So atong R kay RP is equal to 0. So for a given field current, the open circuit voltage is 12 kilovolts, no? Then calculate the armature current for maximum power condition. So ang gingon dali kay maximum power condition. So for maximum power condition or developed, the power angle is equal to 90 degrees. So first is to solve for our EP and VP, no, using the same formula para makuha na to ato ang armature current, no. Gamitan nato tong E is equal to V plus I times Z. No, the same ra japon siya og concept. Ang ato lang dari is we don't need to solve for the angle. So example number 1, nag-solve pa ta sa atong angle. But this time, since ang pangitanan nato is the maximum power, so given na nga nga atong angle is already equal to 90 degrees. So solve for EP, that is 12 kilovolts. So tara, open circuit voltage of 12 kilovolts. Dayon na pud tay given nga 11 kilovolts ato ang terminal voltage. So kaning mga given diri, always ni siya nga katong VP nato, no, or VL, no, line voltage or voltage per phase. So kaning given, it is our VL or line voltage. So we need to convert this in per phase nato nga voltage. So that's why we divide it to square root of 3. So we have 11k over square root of 3. So we have this VP na dayan. VP and VP. Dayon, without solving na sa atong angle, so we substitute na sa atong values directly, no? So si VP always nga 0 ihang angle, then si EP is katong angle na 90. So that's why we have our EP 69.30. Kanina gi-substitute nato diri angle 90, dayon atong VP kay 6.35k, or that is 6,350 angle 0 over our impedance, which is equal to J6. No, i-plug in lang ni sa calculator. So our expected nga output is equal to 1,566.55 angle 42.5. So do not forget nga ang atong calculator dapat naka-complex mode, no, para maka-input ta aning mga angles and kaning mga imaginary nga naman numbers. So our final answer here is equal to 1,566.55 amperes. No, masayon na siya i-solve basta ang giingon na kay maximum power condition. You don't need to solve for the angle. So next is about the power losses and efficiency of the alternators. So how do we solve the efficiency sa alternators? So efficiency is equal to the output power, or the power delivered, over the output power plus the losses. So what are these losses, power losses? So we have the armature winding copper losses, we have the field winding losses, napud tay core losses, then napud tay friction and windage loss, no? And the sum of the core loss and the friction and windage losses are sometimes called as the constant loss or the stray power loss. So ma-summarize lang na dayon na to ang formula into P out over P out plus copper loss plus our field winding loss plus stray loss, no? Kani si copper o si field ay si friction kay ma-summarize siya into stray loss. So unsa man na siya nga mga losses. So nag-search ko diri. So first kay ang copper losses or the I squared R losses. So these occur in the armature winding and rotor winding of the alternator. So amo na siya makita dadto daw sa imong armature winding ug sa imong rotor winding. Armature winding man na siya katong sa stator ni mga winding, no? So these losses occur due to the resistance of the windings, no, sa imong wire, no. Ang core losses naman, or what we call the iron losses, occurs at the pole faces, the teeth, and the stator core of the alternator. So the core losses in the alternator occur because the various iron parts of the machine are subjected to the varying magnetic field, no, katong metal mismo nga kung aha gituyok ang imong winding, so those are the, or sa imong rotor baka nga part, so those are the your core losses. So the core losses consist of the eddy current loss and the hysteresis loss, no? So basahan na lang na ninyo ang about sa hysteresis o sa eddy current nga losses, basta kay core losses composed of those two losses. Next is the mechanical loss, which is composed of katong friction losses o katong windage nga losses. So the friction losses occur due to the friction of the moving parts, such as the bearings, while the windage losses occurs due to the friction between the moving parts of the machine and the air inside the alternators casing. Okay, so those are the explanation for the losses. So, na-discuss naman dito no, na ang copper loss is actually equal, or that is actually also called as I squared R nga loss, no? So, dali ra siya i-remember because that is the formula for the power, I squared R, no? I here is the phase current, no, squared multiplied by the resistance of the armature winding per phase. Then for this is for single phase ng alternator. So if three phase naman siyang alternator, so you just have to multiply it by 3. Then for the field winding loss, formula na is equal to the DC voltage applied in the field winding multiplied by the field current, no? P is equal to IV lang. Okay, example. A 25 kVA 22 volts 3-phase Y-connected alternator delivers rated kVA at a power factor of 0.8. The effective resistance between the armature winding terminal is 0.18 ohms. The field takes 9 amperes at 110 volts. If the friction and winding loss is 440 watts and the core loss is 600 watts, so for the percent efficiency, no, efficiency ang atohang isolve. So formula sa efficiency, so by the way madin siya ang sign sa or symbol sa to ang efficiency, no, mura siya N, that is equal to the power delivered or the output power over the output power plus the losses, no, itong upat ka losses. So since ang ato ang friction and winding loss kay given naman, so we have already given na ana, and atong core losses, so atong isolve na lang is the copper loss nato, no, ang ato adeng pong field winding losses, no. So unknown nato kay tulo output po dahil nga power ato po nang isolve. So first is atong isolve si output nga power. So how do we solve that? So given taog apparent power, which is equal to 25 kVA, no? So that is our S. So we already used this formula sa itong previous nga discussion. So the delivered power is equal to the apparent power multiplied by our power factor. So dali ra kayo, 25K multiplied by 0.8, that is 20 kilowatts. So dali ra kayo, nakuha na si P out. Next is to solve for our copper loss, no? Then ang formula sa tong copper loss, that is, since it is a three-phase, no, alternator, then we will going to use the formula nga 3 times I squared R, no? Then ato sang pangitaon si current o si resistance nato. Since ang atong given is ang resistance daw sa atohang terminal, no? Terminal resistance, or that is our RT. So ato sang pangitaon ang per phase na to nga resistance. So RP is equal to this was actually discussed sa to ang previous nga lesson, no? So kung RL or line nga resistance, lahi po yung formula katong 3 halves, no, sa ato ang RT. But since this is for delta, delta connected, since Y connected man ato ang alternator, then we are going to use the 1/2 RT. So 1/2 RT, so that is 1/2 times 0. Ano kong mouse? 0.18. So that is equal to 0.09 ohms. Na natay RP. So for our phase current, so sa Y connected, no, ang ato ang current sa ato ang phase, no, dari current nato dari og sa current sa ato ang line is just equal, no, basta Y connected. So that is equal to, the formula nga atong gamitan is the apparent power over the square root of 3 multiplied by our line voltage, no? Anak ko nga, I'm sorry, kwan day ni 220 din eh. Hindi na 22. Always, this is in VL nga given, no? So our VL is 220. So 25,000 divided by square root of 3 times 220. So that is equal to 65.6 amperes. No? So formula in getting the line current or the phase current. So equal na siya if Y connected siya. So after getting our phase current, then na po tayo phase resistance. So ato na po ng substitute na dayon. So 3 times our current, that is 65.6 squared multiplied by our resistance. Then we have our copper loss na dayon. Then for our field nga loss, no, field winding nga loss, so dali ra kayo siya, that is just equal to the voltage, DC voltage applied in the field winding multiplied by the field current. So since given naman tanaw na may nakabutang sa problem nga the field takes 9 amperes at 110 volts. So this is our IF, then natay VF. So multiply lang 9 times 110, that is 990 watts. No? So nakuha na nato pod si field winding nga loss. So after that is aton nilang dayong i-substitute ang mga values nila. So output power, that is 20 kilowatts tara over output power plus our copper loss kanay, then our field winding loss dayon given dayon nga duha nga core loss of katong friction nga loss, then multiply by 100%. So our efficiency here sa to ang alternator is equal to 96.236%. So sa pasabutan na, so mas dako ang efficiency, mas better ang performance sa imong alternator. Okay? So next topic is about parallel operation of the alternators. So alternators are connected in parallel in order to avoid overloading the alternator, since each of the machine, no, or the alternators in parallel operation will share a common load. But dili siya basta-basta, no, nga mag-parallel ka sa imong mga alternators. So there are requirements for alternators in parallel operation. Number one is they should have equal magnitude of terminal voltage, no? Katoto ang V. Next is they should have the same operating frequency. Then lastly is they have the same phase sequence. Okay, muna siya ang mga requirements sa para pwede na ito ma-parallel ang ato ang mga alternators. So, how do we solve for the voltage of the load, no? Voltage sa atong load, or that is VL. Kani, voltage sa atong load. By the way, this is our load. No, then given tag duha ka generators that are in parallel, no? Duha ka generators. We have generator A and B. So the formula for that is equal to our EA sa itong generator A, generated voltage per phase sa itong A over its impedance plus generated voltage na po sa itong generator B over the impedance sa itong generator B, and so on, no? Kung nakaparallel kung daghan. Over 1 over, or the inverse of our impedance sa itong A plus inverse sa itong impedance sa itong B plus the inverse of impedance sa ato ang load, no? Sa itong load ZL, no? And how do we solve for the current sa delivered by our generator A? So that is given by generated voltage minus the voltage per phase sa itong load, kani VL, over the impedance. So kung B naman po, so katong generated voltage sa itong B minus sa load divided by impedance ni generator B. And ang ato ang IL, or ang atong current sa atong load, is equal to, no, so namatay current dari sa atohang B, napatay current padulong sa atong A. So obvious lang moagi dari nga current kay katong current or sum sa current sa atohang A and B. So that is IA plus IB. Then IL is equal to VL over ZL. So kuan na, no, more Ohm's law, no? V is equal to IL. Okay. No. Then for the power shared by alternator A, no, power shared na to. So PA is equal to the load voltage atong load multiplied by the current, dayon angle sa to ang current. Then sa B naman, the same lang, voltage atong load, dayon current sa to ang generator B, dayon angle sa angle niya. Okay, so for example, natay duha ka generators A and B that are in parallel, and each generator has an EMF of 1000 volts per phase, and they are in phase. Okay, so you're also given with their phase impedances. We have ZA is equal to 0.1 plus J 2. So man ito ang resistance of reactance, dayon napunta sa ito ang impedance sa ito ang generator B. If the common load has an impedance of 1 plus J 2 plus J 1 ohm per phase, so man itong ZP or ZL na to. Solve for the voltage per phase at the load. So voltage per phase, so man siya ang ato ang VP, which is equal to voltage atong load. No, so that is across ato ang load nga voltage. So using the Millman's theorem, no, discussed ganiha, So ato lang tong i-apply dere, then substitute na natong values. So natay EA which is equal to 1000 volts hanggang 0 over the impedance plus ang atong EMF sa atong generator B over the impedance sa ang generator B kani over the inverse sa ang duha ka impedances plus the inverse sa ang load nga impedance, no, kani. So after that, our answer there is 735.18 hanggang negative 20.61 degrees, or our voltage sa atong load is equal to 735.18 volts. So parallel operation naman about if the problem given are the external parameters of the generators. So just to take note that the characteristics curve of the generator is always assumed linear, and the horizontal axis of the characteristic curve is either current or power. So horizontal kaning sa y-axis na to. So either current or power na siya. So these are kanang representation sa ilahang relationship, no? So for the voltage and current, no? So at voltage no load, no, mas taas ato ang voltage at no load, dayon gamay ato ang current. So at voltage naman, at full load gamay atong voltage, then mataas na pud ato ang current, no. Dari man ang pasaka ng mga values, dari pud pasaka nato ang mga values. Okay, so our IL, or that is the current developed when terminal voltage, is VL, that is equal to the current at full load multiplied by our no load na voltage minus the operating voltage or the bus bar voltage divided by our no load voltage minus the full load voltage. So kani mo na po ni siya ang relationship between sa tong power and sa to ang frequency. So pare-parehas ra sila og formula nga gamiton. So this is for the power and the speed regulation. So ang na-change lang ani kaganiha is naka-voltage man ni kay relationship between the current and the voltage. So kani power na pod, so mo ni siya na imong power, then instead of voltage na mo na po siyang frequency. Yari. So kani power and speed regulation. So power then speed regulation. Then there is a relationship between power and speed. No? So natay power dayon sa to ang speed. So for percentage speed regulation of generators, the percent rise in speed of the prime mover to a generator when its electrical load is switched off or unloaded, no? So mataas ang speed niya, of course, kung wala na tay load, mas paspas jud ang speed, no? So the formula for that sa tong percent speed regulation, no, and speed R regulation. So percent speed regulation is equal to the speed, no load speed minus the full load speed over the full load speed times 100%. So if you're going to solve for the no load speed, no, so ato lang ni manipulate ang formula, multiply lang ni siya dari, dayon i-transfer lang si FL sa PCAS, no. So ang atong answer ana is kanin dayon. So no need to memorize this one. So kanilang first na tong formula, then if you're asked to find for the no load speed, then i-manipulate lang nato ning formula sa taas, no, to get this one. So for example, there are two identical alternators that is rated 2000 kVA and operated in parallel. The governor of the first machine is such that the frequency drops uniformly from 50 Hz on no load to 48 Hz on full load. The corresponding uniform frequency drops of the second machine is 50 Hz to 47.5 Hz. Solve the kilowatt shared, so that is the power shared by each machine if the total load is 30 kilowatts. So natay given daw nga ay 3,000 kilowatts. So 3,000 kilowatts na siya. Okay. Okay, so mo na siya daw ang total nga load sa ato ang machine, power 1 plus power 2. So since sa atong problem kay wala man siya gahatag og power factor, then we will assume that ang iyang power factor is at unity, or that is equal to 1. Okay, so we are going to use the relationship between the power and the frequency. No, kay given man ato kay frequency that is. So we are going to use this formula. PL is equal to the power of full load multiplied by the frequency of no load minus the frequency of the load over frequency sa no load minus frequency sa full load. No, so gyud sa man na ngano man na himo ni siyang 2,000 diretso ang atong PFL, no? At PFL, sige to, formula nato is equal to S times PF, no? Then since we assume that our PF is at unity, so meaning kani siya may man siyang 1. So may man na siyang S. So given nato nga S is equal to 2,000 kVA. So manang natay 2,000 dara. Then we have sa atong isa ka machine, ang ihang no load is equal to 50. So that's why we have 50. Dayon ihang full load kay 48. No, so mana 48 ni siya sa ubos. 50 minus 48. Then wala man ta kabalyo sa ato ang frequency sa atong load. So as is lang ato ang FL. Then sa atong second machine, naa siya'y frequency at no load nga 50 Japon, dayon niyang full load kay 47.5 naman. You know? So nanatay duha ka equation. No, naka-formulate tag duha ka equation. So kaning duha ka equation para ma-solve nato ang ato ang FL, no? Para ma-solve nato ni siya. So we will going to use this formula. Equation po nga ato ang na-formulate sa given sa tong problem, no? Kay ang giingon dari nga ilahang total load daw sa duha ka machine kay 3,000 kilowatts. So P1 plus P2 is equal to 3,000 kilowatts. Then substitute atong P1 kani dayon atong P2. So this is to solve for the value sa ato ang FL. So our FL, or frequency sa atong load, is equal to 48.3 Hz. No? Dayon kani siya mo na din nating i-substitute balik sa ato ang equation para makuha na din nato ang value sa ato ang P1 o P2, or the power shared by each sa ato ang machines, no? So sa ato ang machine 1 di ay ihang power nga gi-share kay 1,667 kilowatts, then sa atong ikaduha nga machine kay 1,333 kilowatts. So kung imo na siyang i-add, so ilahang total nga power nga na share kay kaning 3,000 kilowatts. Okay. So I will just leave this for you to read. Dayon I think man na siyang last nga topic. So this is the parallel operation problem given taog load sharing conditions of the generators. So we have apparent power sa atong generator AC generator A ug sa to ang B is equal to the total apparent power drawn by the load. No, so the addition of the apparent power must follow the rule simplifying the complex numbers. So simple lang kayo. The total apparent power of the load is equal to the apparent power shared by the alternator A plus the alternator B. For example, there are two alternators working in parallel. So in parallel, supply a lighting load of 3,000 kilowatts and a motor load of aggregating to 5,000 kilowatts at a power factor of 0.72. One machine is loaded up to 5,000 kilowatts at 0.8 power factor lagging. What is the power factor of the other machine? So, naday duha ka machines dayon ilahang load kay duha pud ka buo. Ang isa kay ang lighting nga load, ang isa kay ang motor nga load. So, take note that sa lighting nga load, ihang power factor kay unity while ang power factor sa tuhang motor nga load kay lagging. Okay? So, first, ipakita na to ang total nga apparent power sa to ang lighting ug sa to ang motor. So, sa to ang lighting, since ang ihang power factor is at unity, no? So, diretso na nga ang ato ang apparent power is equal to katong 3,000 kani. No, times 1 lang man kay unity lang man. So, plus J0 plus sa to ang motor naman is naatay 5,000, no, sa tong motor kani 5,000 kilowatt divided by our power factor, no, power factor nato is equal to iba namatay formula nga power is equal to S times PF. So, ang given nato kay power man, so to find for our apparent power, so i-divide lang nato tong power sa ato ang power factor. No? I-divide lang na siya power factor. So, mo nang 5,000 nga kilowatt nga power divided by our power factor niya which is 0.72, no? Times atong angle, no? Ay hang angle pa di ay. So, remember that power factor is equal to cosine of the angle. So, to solve for the angle, that is actually equal to the inverse cosine of our PF. So, inverse cosine sa atong PF, 0.72. So, ato ang total apparent power is equal to 8,000 kilowatt plus J4819.26 kVAR. So, ang pangutana diri is unsa daw ang power factor sa isa ka machine? So, given tag isa ka machine, no, naman tay isa ka machine nga ang iha daw power kay 5,000 ug ihang power factor kay 0.8 PF lagging, no? So, pangitaon nato ang apparent power sa atong isa ka machine, no? So, atong formula nga gamiton is katong ST apparent total power then sa is equal to apparent power sa atong machine A plus machine B. So, given matag isa ka machine, so atong pangitaon na lang is kaning si machine B, no? So, SB. So, ato lang ni transfer si SA sa pika side sa atong equation. So, may mo siyang negative SA. So, ST minus SA. So, natay total. Kanina solve na to ganiha. Total minus SA. So, kanina 5,000, di ka ni siya ani. Dili malibog ha. Kaning ganiha nga 5,000, di ka ni siya ani. Okay? Sa motor. kani siya kay sa machine or sa ato ang alternator or AC nga generator. So naatay the same lang Japon nga formula tong gamitan katong P is equal to S times PF, no? So to solve for our S, that is equal to power over power factor angle theta. So nga na lang. So natay 0.8 nga power factor nga lagging, no? So kaganiha lagging Japon tong motor. So positive lang Japon ang ato ang angle. So with that, ma-solve na din nato ang nakaana na siya. Ma-solve na din nato ang ato ang apparent power sa ato ang machine 2 or machine B. So na natay answer ani niya. So ang gipangita nato is the power factor man. So power factor agi nato na makuha, that is sa angle nato, no, sa tong apparent power. So power factor is equal to cosine of theta, no? Then for ato lang dayon i-substitute ang value sa to ang theta. So that is 19.617. Cosine of 19.617, that is 0.942 lagging. So ang power factor sa to ang machine B is equal to 0.942 lagging. So for your third assignment, so answer these two problems. So gibutan na ako ang hint ang final answer. So all you need to do is to find for the solution. So dapat mo arrive mo ana nga mga answers. Okay, so that's all for this video. Thank you for listening.